Good evening, everyone. So, myself, Henal Bhatt, a postdoctoral associate from Stony Brook University, and I'm going to present our work on compositional mapping of Tsiolkovisky crater. So, Tsiolkovisky is providing a best example of far side volcanic activity. It is around 180-kilometer diameter and located on 20 degrees south and 130-degree east. So it has very prominent central peak and very fresh exposure of certain mineralogy. And to understand its composition, we have utilized two data sets over here. One is LRO Diviner radiometer dataset, which works in MR region, ranging from zero point 0.4 micrometer to 300 micrometer, and another one is hyperspectral data from Chandrayaan-1 M-Cube moon mineralogy mapper, which works in VNI region, ranging from 520 nanometer to 3000 nanometer. So these both are compositional maps. So left is generated using M-Cube data sets, and left one is generated using Diviner data sets, and right one is using M-Cube data sets. So for M-Cube map, we have created using integrated band depth parameter technique from Mustard et al. And we assigned red channel for IBD1, green for IBD2, and blue for the albedo region of 1570 nanometer. And the left map is CF map generated using Diviner dataset. So CF value for most of the floor basaltic region is falling around 8.2 to 8.4, which is also indicating it is like pure basaltic mare material. And looking at the this IBD-FCC image, we found some albedo or yellow shade color variation. So all those material are basaltic material, and we try to delineate those all spectral units based on color shade variation we found in this area. So we have divided it from southernmost part is TS1 to TS2, 3, 4, 5, 6, 7, and 8. And later on, to understand quantitative abundances of this region, we collected a spectral profile from all the craters present within these units. And the crater size for all those spectral profiles are ranging between 500 meters to 1 kilometer. So these are all spectral profiles we collected and then studied based on its band parameter, like band area, band strength, and band center. And we plotted those results in the band area versus band one center graphs as per the Gaffe et al., which indicates that upper graph, the pink values are all of band parameter values displaying TS1 mineralogy. So most of those parts are displaying pyroxene bearing material in the TS1 region, and TS2 in the upper graph is displaying mostly pyroxene and less olivine rich material. But before this analysis, also looking at this map, I was suspecting that TS2 and TS8 should be a single unit, which has been overlaid by younger unit TS1, which is which shows less crater population, as well as very high albedo in the albedo map, as well as over here also it is displaying very distinct color variation. So this mineralogical detailed analysis are also confirming these results, because those blue diamonds and green diamonds from both of these regions are overlapping on each other. So these are some good findings of this work. The another map, CF map, is also like displaying 8.2 to 8.4 values for all mare material, which is also confirming olivine and pyroxene bearing basaltic material for the basaltic floor. And CF values falls very lower, that we will also show in later on in central peak. So these are the lab spectra of a different mineral mixture like olivine, plagioclase, and pyroxene, analyzed in a simulated lunar environment by Arnold et al. And they created the olivine index, and they studied the emissivity, concavity of these emission profiles. And we also collected emission spectral profiles from diviner data, and we compared our result with this lab spectra, and they are displaying that spectral profile collected from location 1 is consistent with Arnold's lab spectra, which is displaying around a 70-20 ratio for plagioclase and olivine-rich material. The central south location on displaying 2, spectra 2, is consistent with equal proportion of olivine and plagioclase bearing material, and location 3 is displaying mostly anorthositic or pure plagioclase rich material. So in later on, we will see on CF map also around location 3, CF values are falling around 7.4 to 5, which is indicating possibly more pure anorthositic material within this region. Spectral profile collected from 4, 5, and 7 are displaying again 70-20 ratio for plagioclase and olivine-rich material, and profile 6 is consistent with ratio like 20-70 for plagioclase and olivine-rich material. So this is the CF map, and here these blue pixels are displaying, as I said earlier, mostly pure anorthositic material, which we confirmed with spectral profile also. And to confirm or to study with hyperspectral data also, we collected spectral profile from the same region and tried to study the exact band center absorption and the broadening of the area to understand probable mineral mixture using these remote sensing data sets. And results are mostly consistent with the previous results. So concluding the work, Tsiolkovisky crater floor as well as central peak both are displaying olivine content at some point. So crater floor are mostly displaying pyroxene and olivine bearing material except TS1 region, which is located on the southernmost part, and it is underlying a single unit which we divided here as a 2 different units. So it is younger one, and later on it flowed on the TS2 and TS8. So that is one of the finding, and other is central peak at the southernmost part of central peak uplifted one is mostly displaying troctolitic material with probable different proportion of olivine and plagioclase mixture, and southeast part of the central peak is displaying pure anorthositic material. And so this investigation suggests that Tsiolkovisky may have been created through very intense impact that may have caused a very deeper material like olivine to being exposed on the surface. The other reason should be, or possibly, is that there should be a subsurface pluton that may have like given a chance to olivine being exposed on from the far side thicker crust of moon. So that's it. Thank you.